matrix number is 202972. So the test given on the MTH3101 advanced calculus is to differentiate and explain about Rolle's theorem and mean value theorem. So I will go for Rolle's theorem first. So from Rolle theorems, the first statement said that let f be continuous on the closed interval a and b and differentiable on open interval a and b. So which is the function must be continuous and differentiable. Okay, it must continuous on closed interval and must be differentiable on open interval. Alright. Second, it said that if fa equals to fb, so then there is at least one number c is actually a critical point in interval ab, such that f prime c is equal to 0. Alright, so basically about Rolle's theorem actually talk about more about the gradient, or we call it tangent to the curve, which is tangent to the curve is actually equals to the x-axis of the graph. Alright, so basically Rolle's theorem doesn't talk more about anything else, but it was focused on the gradient of the tangent of the curve. Alright, okay, then let's move on to the mean value theorem. Alright, mean value theorem actually is almost the same as the Rolle's theorem, but for mean value theorem, the statement said that if f is continuous on the closed interval ab and differentiable on the open interval ab, then there exists a number c, same as the previous one, which is c is a critical point. So there exists a number of c in the interval ab. Okay, such that there's equation which is f prime c is equal to fb minus fa over b minus a. Alright, so the equation actually is talk about the gradient at the tangent c. Okay, so maybe the word is a little bit confusing, so I try to make some summary and some comparison using the table. Alright, so there's actually more theorem, right? Rolle's theorem, mean value theorem, intermediate value, Cauchy, Taylor's, Maclaurin, and more of that. But let's highlight first on Rolle's and mean value theorem. Alright, so the summary that I can get is, firstly, if we draw a graph of curve, this is actually for Rolle's theorem. Okay, Rolle's theorem. If we draw a graph of curve, the tangent of the curve, point C is critical point, that exists at somewhere between the endpoint is parallel to the x-axis. Right. Second, for mean value theorem, if we draw a graph of curve, any 2 points on that curve that connected is parallel to the tangent point C that exists on the curve. Okay, since this a little bit confusing, so maybe I can try to draw the graph and show you how to differentiate between these two theorems, right? Okay, since maybe there's no any example to show, so it's a little bit confusing. So let me show you how to differentiate between Rolle's theorem and mean value theorems. Okay, using the graph, you actually can differentiate by using the graph only. So first, okay, for Rolle's theorem, okay, if we have some graph over here, okay, so this is 0, this must be a axis y axis, right? And this is the x-axis. Alright, okay, let's say we have maybe we have some curve. Okay, some curve. Okay, so the critical point at here, this is a critical point. Okay, this is point C, this is point C. Okay, maybe this point A and maybe this point B, right? So within this two interval, within interval A and B, there's a tangent, right? The tangent, okay, the tangent. Okay, so if we look truly this graph, we can see that actually the tangent at the critical point C actually is parallel to the x-axis. This is the axis and this is the tangent C. So you can see this is a parallel line, right? So this is for the Rolle's theorem. Okay, for mean value theorem. Okay, for mean value theorem, okay, let's say we have an axis. Okay, this is y-axis. Okay, and this is x-axis. Okay, so let's say we have some curve over here. Okay, let's say this is point A and this is point B. This is A, this is B. So, and let's say this is C. This is critical point, which is C. So if we have any tangent line over here, and if we connect the point A and point B, and these two is connected, if you can see truly this example, you can see that point C, tangent at point C and the tangent at the point A and B connected are parallel, and we can see that they have the same gradient, right? So these two graphs actually show the different already, right? So look, if we Rolle's theorem, then the tangent C must be parallel to the x-axis. If it is a mean value theorem, the tangent must be parallel to the point, to the any 2 points that are connected. So as for the comparison, okay, from the explanation itself, actually you can clearly see that the critical point C for Rolle's theorem is parallel to the axis, while for mean value theorem, actually the critical point is parallel to any 2 points on the curve that connected to each other. So this is for comparison from what we call comparison for maybe how it looks like. But maybe we can use some example for maybe calculation to show that any difference between these two. And basically these two theorems have quite different on the calculation, so maybe I can show you some example. Alright, firstly I will show example for Rolle's theorem. Okay, so the given function is fx equals to x power of 2 minus 3x plus 2 on interval 1, 2. So the question is determine whether Rolle's theorem can be applied or not. Okay, there's two steps actually. Okay, first step, as the statement I said before, to get at least one number C in interval A and B, FA must equals to FB. So firstly we need to prove whether this equation, whether FA and FB is equal or not. Okay, so firstly we need to check for the FA. This is A and this is B. So for FA is 1, and copy back from the equation. X now is 1 power of 2 minus 3 times 1 plus 2. Alright, so it's equals to 0. Alright, so this is for FA. And how about FB? We need to check FB also. B is 2. Okay, so 2 power of 2 minus 3 times 2 plus 2. 2 power of 2 is 4 minus 6, and plus 2 equals to 0. Right, so now we see that FA is equals to FB. So it means that Rolle's theorem still can be applied, but then we need to check what is the number C, or what is actually the critical point for the function. So to find the critical point, first we need to differentiate the original equation first. We need to find the f prime x. The f prime x is, so differentiate x power of 2, we got 2x. Differentiate negative 3x is negative 3, and differentiate 2 is 0. Alright. Okay, as I said earlier, f prime c must be equals to 0. So f prime c actually is the f prime x, right? So this equation, you just change x to c, which is f prime c is equals to 2c minus 3, and this equation must equals to 0. Okay, so to find c, just using the simple algebraic method, which is we can get c is equals to 3/2. Right, so maybe if we draw a graph, and we have the curve, so maybe this is the c, this is the 3/2. Right, so that's all for Rolle's theorem. Okay, for now let's move on to mean value theorem. Okay, so the condition to determine whether we can use mean value theorem or not, first we need to check if this function is differentiable and also continuous. Okay, first we check x power of 2/3. Of course it is differentiable, and also this one is actually continuous. If we draw a graph, it is continuous. Okay, now the equation, it's an equation, it's actually a formula for to get for mean value theorem is f prime c equals to fb minus fa over b minus a. This is actually the gradient. This is actually the gradient at the tangent c. Okay, so we need to find the f prime c first. So from this is given that from interval 0 and interval 1. So this is a, this is b. So firstly we need to use the formula, and we just put into the formula. Okay, so for fb, so f prime c equals to fb, b is 1 power of 2/3 minus 0 power 2/3 over b minus a. B minus a is 1 minus 0. This is equals to 1. Right. Okay, then so after we differentiate the equation, okay, so now we know that f prime c is equals to 1, right? So we just change it to f prime c equals to 2/3. We change x into the simplest form in term of c, which is 1/3. This is c, and f prime c already equals to 1, so we equals this to 1. Okay, so then we just using the algebraic method and left out with 2/3 will equals to c. Alright. Okay, so now we can get c. C is actually, we get a point number which is 0.7336. Alright. Okay, so now actually this means that if we draw a what you call graph. Okay, let me show the example. Okay, if we draw a graph, alright, so let's say this is point A, this is point A, let's say this is point B. Okay, so this is point C. Point C is 0. Point A is actually 0 and point B is actually 1, right? So and point C actually is 0.8736. So maybe around here, or maybe here, I don't know, anywhere, something like that, right? So let's take maybe this is the C. So if we draw the tangent, alright. So the tangent, okay, this is quite difficult to draw, okay, but we know from the graph, the tangent at the point C and the tangent, the line, if we connect between point A and point B, must be parallel. So if we draw the graph using a real scale, we get maybe more beautiful part. Maybe, okay, let's say this is the gradient. Alright, so that's all for mean value theorem. Alright, I think that's all from me for Rolle's theorem and mean value theorem. Okay, thank you for watching.